In this video, we will try to solve a problem that was asked in JM Economics paper of 2021. It was asked by a brother to solve it, so I will just try to solve this very question. The question is like this: let k belongs to the real number system. Which of the following statements is or correct for the roots of the quadratic equation? So this is a multi-select option question, okay? And we are being given a quadratic equation: x square plus 2 k plus 1 x plus 9k minus 5 is equal to 0. Okay, we have to see which of these statements is correct for the roots of this very equation, okay, quadratic equation, obviously. Okay, so let's try to figure out first what we have to do. We have to find out the roots for this very equation and to see whether they are real or positive. The options are given and we will see what is the correct option to this question. Okay, so we are being given a quadratic equation. Okay, so let me write it here. So we have x square plus 2k plus 1 x plus 9k minus 5 is equal to 0. We have this quadratic equation. Okay, here you can easily see the coefficient of x square is 1, the coefficient of this x is this 2k plus 1. Okay, and the coefficient the constant term is this. Okay, let's write the coefficient of this is 1 here, so I will write this as a, this is b, and this is c. Okay, these are the coefficients of x square, x, and obviously we have the constant term. So to see whether this quadratic equation has the real roots or complex roots or equal roots, for that what we need to see, we have to see the discriminant of this quadratic equation. Okay, so let me write it here. How do we find the discriminant? It is very simple. So first I will write the quadratic formula to get the value. So quadratic formula is like this: x is equal to, okay, minus b, okay, plus minus under root of, I know you know it is actually from the basic mathematics. Okay, so we have here b square minus 4 into a into c, okay, upon 2 twice a. Okay, so for this equation to have real or complex roots, what we need to see, we have to see we have to concentrate on this very term. Okay, so let me write it here. If let us write let's denote it by d. Okay, if this d, if the discriminant, we call it discriminant, if these terms are let me write it like this, if they are less than 0, okay, if this comes out to be less than 0, in that case we have complex roots. Okay, let me write it here. The brother has asked me to explain, so I am just explaining it also. Okay, if these terms are less than 0, okay, then we will have roots that are complex in nature. Okay, similarly, if this discriminant is greater or equal to 0, okay, if we get this value either equal to 0 or greater than 0, in that case we have real roots. Okay, real roots. Okay, now let's concentrate on the question. Okay, that means we need to see what is the value of this term here. Okay, what is our b? B is this 2k plus 1. Let me write it here. So our b will be equal to, so I am just writing this very thing here. I have to concentrate on this thing only here. So what will be our b? So in place of b we have 2k plus 1 whole square. So in place, let me write it here. So we have to see b square minus 4ac, and our b is this term here, this coefficient, that is 2k plus 1, and it is squared, so let us square it here. B square minus 4 which comes from formula into the coefficient of the first term which is 1, so I will not write it here, and the constant term is 9k plus 1. So let me write here, sorry, 9k minus 5, 9k minus 5. Okay, let us see first solve for the complex one. Okay, if this thing comes out to be less than 0, then we will have complex roots. Okay, I am not looking at the options at all first. So let's see what will happen then. What will be the value of k if this thing comes out to be less than 0. Okay, so we have this 2. If we expand, this will become 2 2s are 4. So this becomes 4. This is k plus 1 whole square minus this is 9. 4s are 36k, 36k minus minus is plus, so we have 5 4s are 20. Let me write it here, it should be less than 0. Okay, obviously we have to check for this also. First we see what will can we factor this out. So this is a plus b whole square, so it is very simple, a square plus b square plus 2ab, which you have, which you obviously know. So we have 4, so this will become k square plus 2 into 1 into k, this is 2k, plus 1 square is 1 minus 36k plus 20, it should be less than 0. Okay, now if we just multiply this 4 to each of these terms, this becomes 4k square plus 4 2s are 8k plus 4 minus 36k plus 20 should be less than 0. Okay, so 8k minus 6k go as 28k, so I will write here 4k square minus 20 8k with 2 gay 2, so I will write here 24. It should be less than 0. Okay, if we can factor out 4 here, 4 and 4, so let us factor this out. So we are left with k square minus 4 7s are 28, so we have 7k plus 4 6 are 24 should be less than 0, and obviously if we transpose this here it will get divided, so 0 divided by 4 will be 0. Okay, I will not write, I will skip this step here. Okay, so I have just transposed that very 4 to the RHS. Okay, now this thing to be less than 0, there can be two, or rather let me first factor this out. If I can factor this out, so we will use the splitting middle term. Okay, what is our middle term? The coefficient of the middle term is -7. We should get two numbers in such a way that their sum should be equal to -7, and the same two terms, rather the same two numbers should give us the product equal to 6. Okay, so very simple, you can guess it. Uh, two numbers such that their addition is 7 -7 and their their multiplication is 6. Okay, if we write it here, -6 minus 1. Okay, -6 plus -1 is -6, -7 -6 into -1, minus into minus is plus, 6 ones are 6, so we have -6 and -1. So this can be written like this, k square, in place of this -7k I will write -6k, then we have this -1k -1, or I will write it -k. Okay, 1k -1k, it is same, plus, okay, in place of 6 I can write like this, -6 into -1. Okay, it will not make any difference because minus minus is obviously plus here. Now we will factor out this. I'm just trying to explain to the brother that he's asked me to explain it clearly. Okay, so I'm just trying to show how it's done. So let's take the factors common. Okay, So in the first two terms we can take k as common, and we are left with k minus 6. Okay, here in the last two terms we can take minus 1 common, because this is minus 1k, here we have also minus 1. So if we take minus 1 common, we are left with this k minus 6. Okay, k minus 6, and obviously it should be less than 0. Okay, now taking this k minus 6, k minus 6 common, so we have k minus 6 into k minus 1, it should be less than 0. Okay, now for this to be less than 0, there can be two conditions. Okay, what are the two conditions? Either this k minus 6, so when we get negative, when we get a number that is less than 0, okay, let us see. If we have two terms, there can be, obviously these are multiplied. If we have here two terms, k minus 6 and k minus 1. Okay, so for this to be less than 0, either this k minus 6, either the first term should be negative, second term should be positive, or first term should be positive or second term should be negative, because minus into plus is minus, plus into minus is minus. So we will have two conditions here. Okay, so we have two cases here. Let me write here, we have two cases. Either this k minus 6, either first term it should be less than 0, or second term, that is k minus 1, it should be greater than 0. Okay, obviously either this first term is negative or second term is positive, then we will get the whole this thing less than 0. Okay, and another case can be either k minus 6, that is k minus 6, either the first term, this first term is greater than 0, or the second term, this term k minus 1, it is less than 0. Okay, now let's try to see which of these things satisfy our this constraint, that is this whole thing should be less than 0. Okay, now if k minus 6 is less than 0, that means either our k should be less than, if we transpose this will become plus 6, either k should be less than 6, or k should be, similarly transposing this minus 1, it will become plus 1, so k is plus. Similarly here we have k, if we transpose this, let me write, which implies here this should be greater than 6, or k should be less than 1. Okay, now let's see which of these cases satisfy this very relationship. Okay, so if k is less than 6, in this case let us concentrate on these two terms. If k is less than 6, okay, what is the number less than 6? Let us say k is 5. If we have here 5, okay, let me write it here to make it more suitable for you people. So we have k minus 6, k minus 1, it should be less than 0. Okay, when will it happen? I am just talking about the first term, whether this very this very relationship satisfies this function k less than 6. So what is a number which is less than 6? Let us say we have k is equal to 5. If k is equal to 5, then we have 5 minus 6. Obviously here we have 5 minus 1. So 5 minus 6 comes out to be minus 1, and here 5 minus 1 comes out to be 4. Okay, I hope I am making myself clear. So minus 1 into 4, it will come out to be minus 4, which is obviously less than 0. Okay. So here we can obviously see this k will satisfy our relationship. Okay. Now coming to the next k should be greater than 1. Okay. K greater than 1. What is a number which is greater than 1? Let us say we have 2. Let us say when k is equal to 2, whether this will hold in this relationship. So we have here in place of k, I will write 2 minus 6. Then we have 2 minus 1. Let us see, 2 minus 6 is minus 4. Yes, 2 minus 6 is minus 4 and 2 minus 1 is 1. Okay, so minus 4 into 1 is minus 4, which is less than 0. Okay, that means this k also satisfies our this constraint. That means when k is greater than 1, this whole thing becomes less than 0. Okay, now these two things we are done with these two things. Now let us say whether this option is correct, k greater than 6. Okay, let's take any number which is greater than 6. Let's take 7. Okay, so if we take k is equal to 7, so k uh, in place of k, if I write 7 minus 6. Okay, so we assumed k greater than 6 is 7, so let us write here 7 minus 1. Okay, now 7 minus 6 is 1. 7 minus 6, 7 minus 1 is 6. So obviously we will get 6, which is greater than 0. Okay, which does not satisfy our, or let me write, which is not less than 0. Okay, so this number will not satisfy our this relationship. Okay, and similarly let us concentrate on the last term. Okay, k less than 1. Take any value which is less than 1. Let us take less than 1, we have 0. Okay, so let's say in place of k we have 0. So 0 minus 6, 0 minus 1. So we have 0 minus 6 is minus 6. So 0 minus 1 is minus 1. So minus into minus is plus. We will get 6, which is greater than 0, which does not hold this very condition here. Okay, so or we can write it is not less than 0. Okay, so this also will not satisfy our relationship. Okay, now the thing is, when k is greater than 1, when k is greater than 1 and less than 0, that means when k is uh, greater than 1 and less than 6. Okay, this very thing I have written like this. When k is greater than 1 and less than 6, at that time we have complex roots. Okay, complex roots, or this whole term, this whole thing becomes less than 0. I will write it here. This k minus 6 and k minus 1, it comes out to be less than 0. When we have these two terms less than 0, obviously we will have the complex roots at that very time. Okay, now let's concentrate on the options. Okay, can we figure out any option here? So k less or equal to 1, roots are real and positive. We cannot say anything because we have only solved for this very thing. Okay, for the complex roots, and we will see for real roots also. Okay, we will not be sure for this very option. Now if k lies between 2 and 4, okay, if it says if k is less than 4, less or equal to 4, or greater or equal to 2, then roots are complex. Okay, let's find out whether this very thing is being satisfied here. Okay, since we have seen k should lie between, I can write it like this: k should lie between 1 and 6. Okay, in the options we are being told that k should lie between 2 and 4. If k lies between 2 and 4, and actually what we got, k should lie between 1 and 6, obviously this 2 and 4 will also be in this interval. Okay, I hope I am making sense here, because k should be less than 6. Here k is less than 6. This thing satisfies condition. K should be greater than 2. K greater than 1 means k is greater than 2, obviously. So this option is correct. Okay, I guess this option is correct. Okay, because here what does this mean? This thing means k should lie between 2 and 4. Okay, but we have seen k lies between 1 and 6. Okay, obviously if k lies between 1 and 6, then k will also lie between 2 and 4, because we will get 2, 3, 4, 5, 6, all numbers between 1 and 6. Okay, so this option is correct. Now coming to the next part, to see whether we have real roots or not. Okay, for that let me rub this whole thing. Okay, so actually I have solved many questions on GM Economics paper of 2021. You can check the playlist IIT GM Economics. You will see a whole lot of stuff on GM Economics. That means, what I mean to say, that I have solved some of the mathematical economics questions there. Okay, so let's see another case now. Now what we need to see, for this thing, for this equation to have real roots, okay, our discriminant should be greater than 0. Okay, so since we have calculated for it less than 0, if we only change it here, we need to see when will be our discriminant greater or equal to 0. Okay, should I rub this? I guess I should rub this. Now let's solve it for first only for greater than 0. Okay, or then we will solve it for equal to 0. Okay, now k minus 6, k minus 1 should be greater than 0. مےٚ باسان یہِ تہِ پَزِ مےٚ مٹاونٕے. Now when these two terms are greater than 0, we will get real roots. Okay, let's see when are the two terms when they are multiplied greater than 0. Okay, now if we have two terms here, let us say we have two terms. These two terms should be greater than 0. Okay, greater than 0 when we multiply two numbers. Okay, when we multiply two numbers, two cases can happen for getting a positive number. Either both the terms are negative, that means here we have minus and minus, or both are positive. Okay, simple mathematics, because minus into minus is plus, plus into plus is obviously plus. Okay, so in this case we will have two situations: either both these terms are greater than 0, or both the terms are less than 0. Okay, let's try to figure out it. Our two cases are either these two terms are either k minus 6. K minus 6 is this term is negative, this term is negative. Okay, so this is less than 0, or k minus 1 is less than 0, or both the terms are negative, or k, let me write it here, k minus 6 is greater than 0, or k minus 6 is, sorry, k minus 1 k minus 1 is greater than 0. The thing is to say here that either both of these terms should be less than 0 to get a number which is greater than 0, or both terms should be greater than 0 to get a number greater than 0 here. Okay, now let's try to see what does this mean. If k minus 6 is less than 0, which it will imply k should be less than 6. Okay, here k should be less than 1. Here we have k should be greater than 6, k should be greater than 1. Okay, now let's try to see which of the k's satisfy our relationship. Okay, now let me write this very thing here again. We have k minus 6, k minus 1. I should get a number that's greater than 0. Okay, now let's see for this very k less than 6. What is a number which is less than 6? Let us say 5. Okay, if we give 5 here, so we have 5 minus 6, 5 minus 1. So 5 minus 6 is minus 1. Here we will get 4, which is less than 0. Okay, but we should get it greater than 0. Obviously this is not our k. Okay, let's rub this out again and see whether this very k will satisfy our relationship. Now if k is less than 1, what is a number which is less than 1? Let us say we have 0, or you can take any number, let's say minus 1. Okay, so if we have minus 1 in place of 1, in place of k we have minus k. Here we have minus 1 or minus 1. Any number, you should pick any number which is less than minus 1. Oh, sorry, less than 1. So obviously I can also take 0, but I have taken minus 1. It's my prerogative here, obviously. So this is minus 6 minus 1 is minus 7 into minus 2. It will become, obviously it comes out to be minus into minus is plus, so we will get 14, which is greater than 0. Okay, that means this is our k. Okay, this very thing satisfies because uh, when k is less than 1, this inequality holds here. Okay, now coming to this 6. Okay, coming to this k. Now k greater than 6, take any number greater than 6. Let us say we have 7. Okay, let's check for 7. So in place of k, I will write 7 minus 6, 7 minus 1. So 7 minus 6 is 1. Okay, 7 minus 6 is 1 into 7 minus 1 is 6. Obviously we are getting 1 6 are 6, which is greater than 0. Okay, so it satisfies our condition. So this k is also of our interest. Okay, now let us see another whether this k satisfies or not. Okay, so k should be greater than 1. K is here greater than 1. What is a number greater than 1? Let us say 2. Let us say let us see whether 2 satisfies. So we have 2 minus 6, 2 minus 1. So 2 minus 6 is minus 4. 2 minus 1 is 1. So we are getting minus 4, which is less than 0, and it does not satisfy our this inequality. So this cannot be our subject of interest. Okay, so there are two things. Okay, any number k should be less than 1. Okay, so k should be less than 1, or k should be greater than 6. Okay, k should be less than 1 or k should be less than 6. Okay, also another condition is if d is equal to 0. Okay, if d is equal to 0, when this thing equals 0, then in this case what will happen? Let me write this very condition, since we were talking about less or equal to. Let's write it like this. Should I take this no, I should not use the equality sign here. Okay, I will check for that very condition also. Let's write when we have k minus 6 k minus 1 when it is equal to 0. Okay, what will be the value of k and here in this case? So simply here k is either k minus 6 is equal to 0 or k minus 1 is equal to 0. That means k is equal to 6 or k is equal to 1. Okay, so we have k is equal to 6 or k is equal to 1. So we can use here when k is equal to 1. So this very condition will also apply. K is equal to 6. Here it is greater than 6. So we can use this here also. Okay, because we are being given the third option was when d was less than when d was equal to 0. Okay, now let's figure out our options. Okay, if k is less than 1, roots are real. K is less or equal to 1. Yes, roots are real. This satisfies our condition in this case. Okay, but the question tells us and are positive. When k is less or equal to 1, roots are real. Obviously, we got real roots. Yes, let us see whether it is positive or not. Okay, to check the positive, let us take k is equal to 1. Since this condition satisfies, let's take k is equal to 1 in this equation. So we have here 2 in place of k, we have 1. So 1 plus 1 is no. Let's take it in this equation. Okay, so when k is equal to 1, when k is equal to 1, that this becomes x square plus now 1 plus 1 is 2, 2 2s are 4x, so this becomes 4x plus now k is equal to 1, 9 into k is 1, so 9 minus 5 is 4, so we should see what will be our roots when k is equal to 1. Okay, so if we factor this out, so x square plus 2x plus 2x plus 2 into 2 should be equal to 0, taking factors common, x plus 2 plus 2 x plus 2, this gives us x plus 2 x plus 2. Okay, which means either x plus 2 is equal to 0 or x plus 2 is equal to 0. Okay, it is same here, which implies x is, if we transpose this here, it becomes minus 2, or here also x becomes minus 2. Okay, so this thing holds k less than 1, roots are real. Okay, this thing is correct. Okay, to this statement is correct, and roots are positive, but we are getting here negative roots. Okay, so this thing is correct, this thing is incorrect. That means this cannot be our answer. Okay, we are getting the real roots obviously, but we are getting negative roots here. Okay, positive not. Obviously this option will not be in consideration. So here C part says as k should lie between 6 and 4. Okay, but we have seen when k is greater than less than 6 or greater than 1, earlier we have seen in this case we have complex roots. Okay, complex roots. Okay, when k lies between 1 and 6, we get complex roots, but here it is saying that roots are real. Obviously this 4 and 6 will also lie between 1 and 6, but the thing is we will get the complex roots, and the option tells us if k lies between 4 and 6, we will get real roots. Okay, and they are opposite sign, but we are getting complex roots when k lies between 1 and 6. Okay, obviously then this option is not correct. D part, if k is greater than 6, when k is greater than 6, we got uh, greater or equal to 6, we got real roots. Okay, this is correct, this thing is correct, up to this it is correct. Now let us see whether the roots are negative or positive. Okay, when k is k is greater or equal to 6, roots are real. Okay, now to check whether they are negative or positive, just plug any number which is greater or equal to 6 in this equation to get the answer. Okay, so for that, let's take a 6 here, k is equal to 6, and put it here. So we have x square plus 2, in place of k we have 6 plus 1 x plus 9 into 6 minus 5. So this is x square plus 6 plus 1 is 7, 7 2s are 14, x plus 9 6 are 54, minus 5 comes out to be 47. Now if we factor this out, this will come out to be 7x plus 7x plus 7 into 7. So this is x plus 7 plus 7, x plus 7. That means x plus 7 should be equal to 0, or this x plus 7 should be greater equal to 0, which gives us x is minus 7 here, x is minus 7. So we got roots are real because we got x is greater or equal to 6, and negative. We also got roots negative. We got roots real and negative. That means this option should be also correct in this case. Okay, I hope I make myself clear in this video. Thank you.